Okay, this is Physical Behavior of Matter, Lesson 5. We're going to review the thought-provoking questions from page 10 in the note packet. I suggest that you get a separate piece of paper before you begin listening to the rest of this lesson because there isn't any room in the note packet to write down the answers to these. Okay, question 1. Temperature and intermolecular forces are two factors that affect the rate of evaporation. Explain your reasoning behind this for both factors. So let's tackle temperature first. First of all, evaporation occurs all the time, at any temperature, whether it's cold outside or warm outside. However, as we increase the temperature, evaporation will occur at a faster rate. Why? Temperature increases, particles are moving faster, they're going to collide more, and they'll be able to escape to the gas state. The intermolecular forces is a little bit more difficult to understand, so I'm going to review intermolecular forces to explain that. First of all, let's look at two different molecules. One is hydrogen gas, which we know Brinkelhoff is nonpolar, so it has London dispersion forces, which is very weak. If you recall from the bonding, so these are weak. And we have water, which is polar, and it exhibits hydrogen bonding. Now, one thing that I see students often making the mistake about, when we say hydrogen bonding, we say that when hydrogen bonds with NOF, nitrogen, oxygen, or fluorine. But we're not talking about the intermolecular forces. We're not talking about the intramolecular forces. We're talking about the intermolecular forces. So, if we look at a water molecule, we know that the oxygen side is slightly negative due to the higher electronegativity, leaving the hydrogen side slightly positive. If I bring in another water molecule here, we know that there's going to be an attraction between the opposite charges here. So the hydrogen bonding, when we talk about hydrogen bonding, we're talking about this bond between molecules. Okay? Hydrogen bonding occurs between molecules when hydrogen bonds with nitrogen, oxygen, or fluorine. So you're comparing something with weak forces, and hydrogen bonding, as you know, is a strong intermolecular force. It should make sense that the weaker the force, the greater the rate of evaporation. Explain how temperature and vapor pressure are related. As temperature increases, vapor pressure increases. So think of a closed container. If you have a gas in a closed container and you begin to heat it, the molecules are going to start moving faster and they're going to collide more, and they're going to bounce off the walls of the container. The pressure is going to increase because the molecules have nowhere to go. So it's a direct relationship. What happens when the pressure above the surface of a liquid is equal to the vapor pressure of the liquid? Well, that's when boiling occurs. As temperature increases, vapor pressure increases until it equals the pressure. As temperature increases, vapor pressure increases until it equals the pressure of the gas above the liquid. Then the substance begins to boil. The particles that make up a solid at room temperature are said to be arranged in a regular geometric fashion. Are the particles that make up a solid still moving? Yes, they have vibrational movement. About a fixed point. Question 5. If the pressure on the surface of a liquid in the liquid state is 30 kPa, the water will boil at one temperature. So this is table H. This is found in your reference table. This has to do with vapor pressure. So if I go down here to the pressure axis, the y-axis, this is scaled in increments of 10. So this is 10, 20, 30. And I go across to where it hits the water curve, and then I can go down and read that temperature. So when I decrease the pressure to 30 kPa, water will boil at 70 degrees. Notice when the pressure is 101.3 kPa, which is standard pressure, 1 atmosphere, or 101.3 kPa is standard pressure. That's from table A on your reference table. I'm looking at the wrong line. There we go. Water boils at 100 degrees, which is what we know it to be. You can also see from this that as temperature is increasing, vapor pressure is increasing, which was addressed in question 2. As temp increases, vapor pressure increases. The vapor pressure of ethanol at its normal boiling point would be what? So normal boiling point, I said, is when something crosses standard pressure. So here's our standard pressure. Here's ethanol. We want this point right here, which is about 80 degrees on this chart. I think ethanol is actually around 78 and change. And 7. As the pressure on a liquid is changed from 100 kPa to 120 kPa. So we're increasing pressure. We're going from 100 to here, which is 120. The temperature at which the liquid will boil will increase, decrease, remain the same, or depend on the liquid. Well, and it says explain your answer. Well, let's look at water because we're familiar with water. We know that water boils at 100 degrees when it's standard pressure. When I increase that to 120, water now boils at 105 degrees. So as you increase the pressure, you are increasing the boiling point. And this is true for all substances, well, all pure substances. If you think about it, pressure cookers that sometimes people cook with increase the pressure. That's why it's called a pressure cooker. So it's greater than 1 atmosphere, the pressure inside the pot. So the water boils at a higher temperature. If the water boils at a higher temperature, then the food will cook faster. Okay, that's it for Lesson 5. Lesson 6 will need to be watched for Tuesday's class.